Passive House Network conference. And I'm hoping that we will see many of you in person in Denver next week as well. So I'm very excited to be the moderator of this session, which is all about the all-American home, new and improved. And I really like that title, so I'm really excited. And we will learn how two amazing companies take an overhaul of the single-family home and meet our current standards regarding comfort, health, and sustainability while using prefabrication to scale up and meet the demand. And I'm Ilka Cassidy. I'm an architect, passive house consultant, and co-founder of Holzraum System. We are a consulting firm specializing in production design of passive houses with natural materials. And I am also co-host of the Passive House Accelerator podcast. So please check that out as well. And now I'm happy to introduce the presenters. Lucas Johnson, the Chief Building Nerd at Valley Homes. Craig Toohey, Marketing and Business Development at Collective Carpentry. And Heather Mott, Designer and Passive House Consultant at Collective Carpentry. And during the presentation, you are welcome to write questions into the chat, and we will answer them as they come up. And then after the presentation, we will talk some more and discuss this updated version of the American icon, the single-family home. So please enjoy.
All right. So welcome, everyone. As mentioned, this is the Passive House Network 2023 conference, the All-American Home, New and Improved. My presentation is titled The Right to Health, Thriving into a Low-Carbon Future. So I'm presenting with my company, Valley Homes, and first going to start with explaining who we are a little bit. We do building science for healthy, low-carbon homes. We do enclosure and mechanical system consulting. We do development as applied research, because a lot of people tell us down here in Arizona that we can't do a lot of the things that we do. So we do our own developments to make them happen and prove that we can truly do good building. And on that note, one of the things we're trying to spread is this concept of good building, which we'll be talking about today. So company was founded by Austin, my business partner. He's the details guy. He digs deeper into everything than I've ever seen anyone do before. It's quite impressive. I'm Lucas Johnson. I'm our chief building nerd and do most of our consulting services. Austin focuses a lot on the development work. So what's the big picture that we're looking at here? And I think we can summarize it as humanity will have a rough future if we don't equitably upgrade the built environment. We need to radically improve entire product life cycles. And just taking a peek at the weather yesterday, I think we've all been experiencing this recently. Weather.com is starting to look like a Netflix action movie, right? It's getting to be a little bit too extreme for my taste. So before we dig into the climate mitigation kind of subject, I want to talk a little bit about this right to health and kind of a lean towards social equity in the built environment. So the right to health as an official construct, 1966, the UN put together this covenant on economic, social, and cultural rights, which included a right to health. Turns out the US Constitution actually has a right to health. So all the, more traditional conservative builders that love the Constitution should say that, actually, you know what? Our Constitution requires that we build healthy buildings. So that's cool to know. The way I like to put this is that all people should have the right to health in the homes where they live and the buildings where they work. So what is healthy? It's a lot more than the lack of unhealthy ingredients. To deliver health in a building requires using good ingredients, but also putting those ingredients together through proper design to make sure, say, rot and mold don't occur. There's hundreds of things that go into this, really, but just some basic top-level summary. Enclosure systems, they need to avoid toxic ingredients, so no more stuff like spray foam, and they need to dry faster than they get wet. We need to optimize indoor air quality through having non-toxic finishes, furnishings, and cleaning throughout the building's operational cycle, and continuous heat recovery mechanical ventilation. Most audiences, I have to fight for this one. I think in this audience, that's pretty much a given. So one of our key sayings is that the ingredients create the results. We like to use the analogy of a meal, right? You can have the best chef in the world with the most skill design such a beautiful plate of food, but if the ingredients that went into it are spoiled, then it's not a very good meal, right? Same thing with building materials. Buildings are what they consume to be built. So here's a great way to summarize this, forcing you to think at the beginning of a product's life cycle. I'm borrowing this image from my buddies at Havelock Wool. We're talking about happy sheep in New Zealand in a traditional industry that's provided a lot of economic, benefits for the country versus large chemical facilities that are harming communities in which they're built and generally not paying the most equitable wages, et cetera, et cetera. That's the beginning of these product life cycles. We need to think about from there until the moment it's used on the building, and then the time when it's being removed from the building eventually. Where does it go? What impacts exist there? And unfortunately, we got to bite the bullet and admit a lot of what we're doing isn't helping. There's a lot of very well intentioned people who truly believe they're doing the right thing, but haven't seen the complete numbers. From a health and carbon impact standpoint, spray foam and other foam insulation materials tend to be some of the worst and the most inexcusable from my hopefully data driven perspective. One little hint about health is if you have to dress up like the CDC to install a type of insulation, you probably aren't doing something healthy. And unfortunately, too many buildings, even certified ones, aren't always delivering holistically. I know we put our best efforts into doing this. Most of the colleagues who I've worked with in this industry for a long time now do incredible work. But there are two failure points that occur still too often, which is moisture driven failures and health impacts associated there. Just general health in buildings, right? Are the materials being used the healthiest materials for the occupants? And then, as my buddy Chris Magwood put it, the carbon elephant in the room. What is the embodied carbon impact of the materials we use to deliver high performance buildings if we're looking at the whole life cycle? So this can be summarized as what I call the efficiency trap, which is this concept of, say, like in the 1970s, we're like, shoot, bad building's not working out. We need good building. It should be healthy, comfortable, affordable, low carbon, durable, socially equitable. Great. But good needs to be quantified. Green's too political. So let's talk about it as energy efficiency. Cool, solid plan. How do we do it? Let's maximize efficiency, collect data focused on proving efficiency was delivered efficiently and it made people more efficient. And then you're kind of starting to think like that's not really the original goal. And kind of it's like, okay, well, we'll sneak in the green. If it's efficient, it does everything good, right? Efficiency solves all problems. Okay. And then, wow, efficiency really caught on. There's certification systems, et cetera, et cetera. And now Passive House perfected efficiency. The world is saved. And then, oh snap, it turns out that high performance just amplifies things. It might look really nice in energy models, but we need to take a much broader perspective of what materials are being consumed, what carbon impact that they have, what health impacts do they have, and look at it from a more holistic standpoint than efficiency alone. So we asked these questions. What about all these original goals? Efficiency was never the core goal. It was kind of the way we framed achieving it. It was the metric we were using. But in my take of things, we are all trying to deliver truly good buildings. Truly good buildings almost always are very efficient. But I've found so many times that if we design for efficiency first, we end up with failures in other areas. But if we design for health and carbon impact, to maximize health and minimize carbon impact, then we end up with very efficient buildings typically that have much better holistic outcomes. So, how do we make design decisions as a company, and how do we specify the good ingredients to make these design decisions happen? So, one of the core concepts that I've been floating around is that sustainability is no longer about doing less harm, it's about doing more good. And with that philosophy in mind, based on the projects we've worked on in our careers, which is thousands of buildings at this point, we created the 5 factors of good building, which is this concept of looking at comfort and health, efficiency and renewables, durability and resiliency, social equity and embodied injustice, which we'll get into in a minute, and life cycle carbon impact, looking at all 5 of those factors holistically when we make decisions around product specification in particular. So, what is it intended to do? Of course, maximize comfort and health, maximize efficiency and renewables, maximize durability and resiliency, minimize life cycle carbon impact, minimize embodied injustice. Embodied injustice is an interesting concept. Many may not be familiar with this idea. I'm married to a culture anthropologist who has taught me a lot about this side of the academic world. And embodied injustice is this concept very similar to embodied carbon, where there's injustices built into product life cycles, such as, war for oil or these chemical factories causing cancer in the people who work there and the communities in which they live, or workers on site suffering from stuff with asbestos or lead poisoning or whatever it might be. The fact that we allow products to go through our industry that have these life cycle impacts, that hurts people. And I don't think we should accept that. And that's the concept of embodied injustice. So, in my opinion, it's long time, past time to tell this story. Going back to that image I showed from Havelock wool earlier, let's trace it from the start of the product life cycle to its use on site. When we're using healthy, low carbon materials, the degree of site, protection you see in this photo is typically what you need. Sometimes you need a mask if you're cutting, wood fiber insulation or something. But the point is, it's a very healthy material for the workers to install, and it's also a healthy material for the occupants to enjoy as they live there, versus these negative product life cycles that end up being, I would say, extremely gross when they're installed on site. So, a tale of two insulation approaches is another way to put it. We've got the worst of times, synthetic, unhealthy, and high carbon insulations. These require ripping apart and dominating the natural world. This leads to suffering through displacement and economic hardships. Workers are exposed to extreme toxicity, poor working conditions, and low wages during manufacturing and installation. And occupants suffer from mold, moisture failures, and sick building syndrome. Then we have the best of times, natural, healthy, and low carbon. These are produced in harmony with nature to sustain environments that improve lives. Workers have healthy working environments and better paying jobs typically, and occupants enjoy healthy, durable, and comfortable, typo there, comfortable spaces. One of our biggest problems is that we dissociate ourselves from the reality of things that are designed. And then when it gets to the job site, it still happens because we just say that work sucks, let the less privileged people do it. To me, this is unacceptable. It's something we need to stop. So, the 5 factors what? It's a design tool, it's not intended to be a certification. It's a guide for integrated design of holistic systems, and then mostly for choosing materials that are actually going to meet your project goals. And one of the things worth mentioning is it works with high performance or low performance budgets. I know we're focused very much on high performance, so I won't spend too much time on this, but it is worth mentioning that good low performance actually can be great. This is my house in Tucson, Arizona. There's me and my kids standing out front of it. We spent less than $15,000 out of pocket to retrofit it from all these gross gas appliances. It's cash flow positive from day one. We're 105% net positive, including charging an electric car. And it's a healthy, durable, comfortable, and extremely low carbon home. So for people who can't afford high performance, good building is still an option. In other words, the way we put it is everybody gets good building, right? We still encourage every building to try to meet Passive House standard, right? We want buildings to maximize their efficiency, but sometimes people can't afford that complication. This is an incredibly cool backyard cottage slash workshop that was built by a client in Phoenix. But it wasn't the most affordable building in the world because they were going for the highest performance as well as part of a leadership example in the community where they live. And little photo update the client just sent of the project, looking pretty darn nice now. Got to get some landscaping and then they're done. So what I want to encourage is a new normal. This is my daughter. I overlaid here what they're saying. Tyvek, really, that's so lazy. Not to rip on Tyvek specifically, but just using just what are considered industry standard membranes and tapes for air tightness when there's so many better options is just crazy to me. And this is my business partner's kid when he was being offered some vegetables as a young man. And this is what I want you to look like when someone suggests foam insulation. Like, this is no longer acceptable stuff. So Zach Semke had put this really well talking to Chris Magwood. I believe this was on Twitter a while ago. as a concept of what good building could be as passive house plus clean energy plus carbon storing materials, that equals good buildings, right? So dig into this stuff, right? The clean energy side and the life cycle carbon impact, including, upfront embodied carbon, or what's often now called material carbon emissions. So the first step in my process that I take here is calculating for context and climate. What kind of building is it? What kind of operational energy are we expecting it to consume? So what's our predicted EUI? Converting that to kilowatt hours per square foot per year so that we can look at the local grid and say, okay, how much carbon is there per kilowatt hour? What is the pounds of CO2 equivalent per kilowatt hour of electricity? So we know, instead of just thinking, oh, efficiency saves some carbon, let's actually look at how much carbon is saved per year by calculating it based on the local grid that the building's connected to. Now, if you're off grid, this is a different thing. But if you're connected to a utility, they do have to provide these numbers every few years in power mix reports. So you can find these numbers and do this. And a little pro tip, limiting fasteners, as you can see here in this photo. Some of our overly zealous carpenters put a lot of staples in the wood fiber insulation around this building and caused some thermal bridging issues that we ended up having to fix. So next step here, after we understand our operational carbon context, what is embodied carbon? What does it look like? Well, first of all, in the little red circle down there, you can see the operational use of the building is a very small part of the overall carbon life cycle of a building. The first part, which is what we typically now call upfront embodied carbon or material carbon emissions, is the process of extraction, processing raw materials into building materials, manufacturing those into final products, transporting those to the job site, and then installing them in a building. There's also an end of life carbon impact that we need to dig a lot more into, but we're not going to focus on that today. So, how do we know these things? There's global standards for this. They're summarized in what are called environmental product declarations, or EPDs, which usually includes what would be considered a life cycle carbon analysis as part of it. When we're looking at the material embodied carbon or the material carbon emissions, we're usually looking at a specific part of these EPDs that typically represent about 70 to 80% of all the life cycle emissions, right? So this is trying to take a look at the biggest chunk that we can understand most accurately. I will say that this type of analysis has reached the point where it's meaningfully accurate, but it has a way to go in precision, as all good science does, right? So one of the areas we found that it's really worth focusing on is the embodied carbon of insulation. Concrete can be really hard to change, really hard to control what the local concrete companies are providing as far as mixes are concerned. I definitely suggest trying to specify low carbon mixes. They're more available now, but who knows if that's feasible. Finishes, clients tend to have a lot of strong opinions on, but no one's really caring that much about insulation. And it really is kind of our secret weapon against the climate crisis to switch from high carbon impact insulation to carbon storing insulation materials. So some materials, spray foam, XPS being the biggest culprits, have very, very high carbon impact. I like to think of this as in pounds per meter cubed or something like that, right? That's the general way we think of these things. Kilograms is often used, but Americans understand pounds better, so it's usually worth converting. And then we have carbon storing materials: wool, wood fiber, dense packed cellulose, cork, hempcrete, straw bale. Straw bale is amazing what you can do with, as I'll show you at the end. So there's a tool now put together by the Builders for Climate Action. It's a free to use tool. It's called BEAM. And it stands for Building Emissions Accounting for Materials. What you do with BEAM is input a bunch of data into effectively a fancy Excel spreadsheet. It's now on Google Sheets. And you, after you put in all of your project info into the spreadsheet here, you then go through different tabs to select your material choices for different elements of the building. So showing an example here, looking at subgrade perimeter insulation for slabs, slab and grade foundations. This is our Valley Muse slab. If you use EPS foam board on average, that's about 2,152 kilograms. If we had chosen to use XPS foam board to get that, theoretical extra R1 per inch compared to EPS, then we would have had 10 times the upfront carbon impact, which would significantly affect our overall outcomes of this building. So this kind of decision is extremely important, which material you use. And the one with the higher value, R value rather, isn't always the lowest carbon overall. And often it isn't actually. So let's look at exterior insulation. Mineral wool is what had been originally specified on our project by the architect. A lot of locals wanted to switch it to XPS, but as you can see, that's an insanely high carbon impact. And we ended up going with wood fiber board because we had the ability to find net carbon storing materials that helped us save a tremendous amount of carbon impact on this project. A little thing I like to mention, because people always bring up aerogel or vacuum insulated panels is super high R value and whatever. Um, these materials have just as high of a carbon impact as their R value number. And what I'd say is space age materials aren't worth using on Earth. We don't need that extreme of a performance, and it's not worth the carbon impact. So looking at the carbon use intensity for 20 years of a Toronto two-story home, this is something I'm borrowing for Builders for Climate Action. High carbon, low efficiency buildings, obviously, are the worst. But what's interesting is that a high carbon, high efficiency building, so like a passive house built with spray foam and XPS, really doesn't save that much carbon overall. This is looking at a 20-year life cycle here. Mid carbon, low efficiency buildings save a good amount of carbon. Mid carbon, high efficiency buildings, now we're getting somewhere. That's pretty exciting. Low carbon, low efficiency, interestingly enough, is actually way lower carbon impact than high carbon, high efficiency. But where we really need to get to is either low carbon, high efficiency or carbon storing high efficiency. This is really gives us a good shot at saving our future, or however you want to put that. So this is that backyard cottage I showed you earlier. If we had used Phoenix average building materials, spray foam, XPS insulation, and all that stuff, we would have had 152,000 kilograms of carbon dioxide equivalent up front, and that would have represented 14 years of operational carbon payback. Instead, by using low carbon materials, wood fiber, sheep wool, that kind of stuff, we reduced that to less than 30,000 kilograms up front, which represents a full carbon payback in less than 2.8 years, even in Phoenix, where there's actually a very, very low carbon per kilowatt hour grid. A huge joy and honor recently is that our Valley Muse project, the one we're doing in Phoenix that I've talked about a little bit, it's 4 units intending to fill in this concept of missing middle housing. It really is a form of a new all-American home that we're trying to promote. The other things we're trying to promote about it is not just building, this micro community, but having the best practices of health to the point of what we call performance enhancing building. And we're also trying to show that you can really minimize the carbon impact up front using relatively straightforward construction approaches. RMI, Rocky Mountain Institute, wrote a report called The Hidden Climate Impact of Residential Construction. If you haven't read this, please go download it and read it. It's incredible. But the key thing I want to share today is they came up with an average upfront carbon impact per meter squared determined from 921 model homes across the US, Canada, and Europe. So we're looking at 184 kilograms of CO2 equivalent per meter squared as this average number we can use. So now we have a baseline to compare things to, and that's very exciting. So looking at our Valley Muse project, if we'd used foam insulation for this project, we would have ended up with foam in the walls, the roof systems, et cetera, creating a total of 388,000 kilograms, which ends up being 447 kilograms of CO2 equivalent per meter squared. So that's almost, or more than double rather, the average upfront impact. That is insane. And our intent is to help, build a healthy building that improves the world. Clearly, neither of those outcomes would occur with foam insulation. So looking at concrete, as something that we all talk about as being one of the highest carbon impact things. What was really surprising to find out is that the foam insulation in this beam model, using the market averages for XPS, closed cell spray foam, et cetera, foam insulation would have been over 10 times the impact of the concrete used in this building, right? So it turns out concrete, yeah, let's solve that. But the first thing we need to do is solve insulation. Way easier also, because concrete is a great building material other than the carbon impact, whereas foam insulation doesn't typically meet people's durability or performance or health outcomes that they're looking for either. So there's huge benefits in switching to carbon storing insulations. So obviously we used good insulation. This is my older daughter stuffing some Havelock wool in a little gap space. And there's me walking around the perimeter looking at some of the wood fiber insulation that we had to do some pretty advanced stuff to protect from moisture. But anyhow, that's not this presentation. So Valley Muse with good insulation. We still had the same footing and slab impact. We used a recycled EPS for our foundation walls. We used wooden wool for our exterior walls, and we used blown cellulose for the roof system. And by doing that, we were able to reduce concrete so that concrete is now 65% of the total impact rather than it would have been only about 10% of the total impact in the foam scenario. But more importantly, what we were able to do is create 87% less material carbon emissions than the Phoenix standard, which is 68% below the RMI average that I presented of 184. And this is, per square meter. So Valley Muse, taking a little look at someone's, example of how we did some of this stuff. If you walk down the driveway and take a left, you go through these little, we think of them as private slot canyons. It's a great place to get some shade in the desert. You go up to this balcony that exists between the units, and we had continuous air tightness that got us to 0.3 ACH50. I know you guys probably care about that. Most people in Phoenix say, what is that? And then we had wood fiber insulation placed around here using all non-toxic materials, all red list free. And then we created a drainage channel out, and this is the final product that exists there now with a Koya wood and 3-coat natural stucco, which stucco is another huge element of carbon impact. Synthetic versus natural makes a huge difference. Here's the living room with a wood slat sound wall that's placed over sheep wool insulation. The sheep wool's there for the low carbon, the health, and for helping modulate humidity levels. We found our buildings with the wool insulation exposed as such have been able to stay in a more comfortable humidity level, even though it's very dry outside in Phoenix, right? One of the big problems we have is humidity levels are too low, and that causes viral transmission issues, itchy eyes, all kinds of gross stuff if you have humidity levels that are too low. So the wool is, point is, the healthy low carbon materials have worked way better than conventional synthetic materials in the performance they've delivered and also the carbon impact. So up next, we have a project called Dancing Raven. It's going to be with rammed earth and straw bale, but also meeting passive house levels of air tightness and insulation. And using those materials, straw bale in particular, allows us to save a crazy amount of carbon impact, which then brings us all the way to 81% less material carbon emissions than that RMI average. So this is another step in the right direction. Still haven't gotten to carbon neutral up front. We're working on trying to get there. And then another project we're working on, we're calling it the Valley Hideout. Shout out to kind of the desert, cowboy finding a shady place to hang out. But this is a concrete-free, red list-free, and passive house ready building. Obviously, with the size of a backyard shed or office, passive house is a very tough thing to do. But the air tightness levels are going to meet that. We're using T-stud, the full system, to reduce thermal bridging dramatically, using passive house compliant windows, et cetera, et cetera. And with all of that put together, and just blown cellulose insulation. So very standard, very easy to build. The Phoenix carpenters have had no problem with this, whereas the other stuff we've done, they've definitely had some problems with. We achieved 84% less, but even the ground screws still have some carbon impact. So, it's less than concrete, but still stretching towards that zero or carbon storing up front. But we're very happy to share these stories. If you like this kind of stuff, following us on Instagram, we put a lot of effort into trying to keep people up to date with what we're doing and why we're doing it. And again, I'm Lucas Johnson with Valley Homes, and thank you so much.
All right. Thank you, Lucas. Hi, everyone. Thanks for joining this session. Thanks to the organizers for putting on this conference. Thanks to Ilka for moderating. As a bit of background, the original pitch from our side for this presentation was to talk about Passive House as a systems approach and why it needs to be in relationship with robust building systems in order to be effective, affordable, and widespread. So we sought to take lessons from Europe about how companies and approaches to building are really trending towards light manufacturing and systems approaches. And to show how we're working towards a similar goal here in North America. When the organizers asked us to talk about how we're overhauling the all-American home, we thought, okay, great, let's break down this concept and see what it is we're really trying to improve and how. So a quick rundown, I'm going to briefly introduce the company, go over a few definitions, talk about some theory, then why we think the all-American home needs an overhaul, summarize what I call the trifecta of quality building, and then provide a high-level look at what we call our building system. Then Heather's going to go over some of the design tools we use both externally and internally. And finally, we'll get a bit more into the details of this first of our collective home projects as a case study. Collective Carpentry is based in Invermere, British Columbia, was a general contractor turned into what we call element producer. So basically prefabricating panel systems along with structural site installed parts. We're really focused on passive house and high performance. So really all of the assemblies that we do are very thick, well insulated, thermal bridge free, good details, that kind of stuff. For this type of construction, we've done over 70 structures, in closed panel fashion since 2013. So we have a bit of experience. Those are mostly single family, but we've done a few other building typologies as well. And we really do everything from design and 3D modeling through fabrication, ordering and sometimes pre-cutting structural parts, glulam beams and others. Working with CLT, doing delivery and installation ourselves as well. This is a little map of some of the places that we've been in the past few years, 3 Canadian provinces, the Rocky Mountain region, and the Pacific Northwest and California. We are registered and licensed in all these places to do work as a subcontractor. In 2022, we released some pre-designed homes, and this is really our effort to just put in practice everything we learned about good design and good material selection and good building systems, and really offer something to the market that at least acts as a good launch pad from which to find something that clients are looking for, because sometimes they want a good home, but a custom home design process is a little bit out of reach. We also last year revamped our standard details, which is partly for internal use, just for clarity of sort of the direction that we're going, but more so for outside designers we work with, who anything from single family homes to larger multifamily projects. This is all applicable. We're currently working on our production improvements, and this is like how we're focusing on improving quality, speed, capacity, etc. Things like monitoring and forecasting of production, real time, reorganizing how we prep material for our production process, running 2 production lines, incorporating European equipment for moving panels, stapling, nailing, those kinds of things. Starting to get to this light manufacturing without necessarily full automation. So for some definitions, the first question I had was, okay, how should we define this all-American home? And I just kind of cheated and asked ChatGPT, because I love ChatGPT, and ChatGPT gave me some answers. Heather suggested I shouldn't use this, but I just went ahead and did it anyway. ChatGPT sort of said some things about single-family dwelling and architectural styles, some things about vernacular architecture, picket fence, the American flag, So what I just sort of thought is like, let's use this. We'll come back to it and we'll discuss like what about this might need to be changed with this current ChatGPT model of the all-American home. Now, overhaul, if we're going to overhaul it, this overhauling is really the thorough examination of machinery or a system with repairs or changes made if necessary. So we're going to be thinking here about the home as a system on many levels, and the process of overhauling it being really looking at the system and asking where and why it's not working. And then, a system, if we're going to take apart a system, let's agree that a system is a complex set of relationships and interactions between different parts. So this can be something that's large scale, like the climate system, or it can be small scale, like a local food system, or maybe a ventilation system or an air tightness system. But it's organized, it's working together. It creates a whole that is greater than the sum of its parts. I also want to just briefly introduce some concepts around patterns, systems, and quality building. I was really fortunate to have had the chance to take a 4-day course with Monty Paulson and Passive House Canada last fall about pattern languages in Passive House, and how identifying and recycling these patterns is really the best, most reliable way to do Passive House multifamily at minimal cost. I really loved thinking about all of these really specific and really broad patterns we're seeing in smart design, and how crucial they are to creating good projects that are really built efficiently. So for anyone that's interested, take this course, read this book if you haven't already. These are some of the patterns that Monty presents. Some of the things that I think he calls patterns to me are maybe more systems, and I'll get into that in a second. I did kind of dig into this a little bit deeper out of curiosity and got into reading The Timeless Way of Building, which is his other sort of seminal work from Christopher Alexander. And I really enjoyed his higher level thinking about the quality without a name. And to me, this is what we need to be striving for as we look to revitalize the all-American home. I particularly like this use of 3 terms to describe quality without a name, those in bold here. You can really feel when a building is alive. It feels whole and it's comfortable. And on the contrary, you can really feel when a building is dead too. So keeping this in mind. Then, what fewer people know about, but what I was happy to discover as I dug deeper was Alexander's earlier writing, which was 9 years before a pattern language. And this one is on systems generating systems. What he says is that there's 2 hidden meanings in the word system. The idea of a system as a whole with holistic properties that can only be understood by the interaction among its parts, and a generating system or generating systems. These are the systems that underlie the holistic system, and they all work in relationship to create something that he would say is alive. Emergent behaviors come out of these systems, which become patterns and eventually pattern languages, which we see in architecture and urban design, but also, I'd argue in our education system, our culture in general. What I found really important about what Christopher says is that the most important part of a system is its stability. And in this sense, I want to make the case that the all-American home, what it lacks is stability. So the current model for the all-American home is no longer stable in the face of a changing climate. 60,000 people are estimated to have died in Europe last year from heat-related causes, and I'm pretty sure we all live on that same planet. So, some of what we've lost sight of, which the all-American home originally accomplished, were some of the vernacular designs that made these buildings more climate appropriate. And the more homes have become financial assets more than homes to pass down through generations, the more the quality has suffered, and the people, the occupants, are no longer at the center of the process of building a home. In the sense that today people are living smarter with access to better information, they're eating healthier, as Lucas kind of alluded to, with better ingredients, right, in buildings, and maybe more so what they eat, and driving less, connecting to nature. They're choosing to eat organic, but they're not necessarily choosing to be housed in according to these same values, because the solutions are often too bespoke or expensive and out of reach for them, and Passive House especially. So the all-American home in its current form doesn't serve these needs that people have. But we're not really saying that everything needs to be changed. We want to keep going back to that definition, the family-oriented design, the American flag, which after all represents a country known for its innovation. We just need better systems of design, construction, and material use to work together to deliver something that's better and more durable and long-lasting and sustainable to address what's not working with the system. So, we don't really have time to mess around. We need to start doing this right away. So we need to choose these systems of design, construction, and housing that will create predictable results. We need to iterate, we need to repeat, And then we also need to, I think we need to keep our solutions somewhat human scaled so that the social context of building is still prioritized. And we don't just get into like ultra mechanization of everything. Choosing these systems, choosing these generating systems, as Christopher Alexander would call them, will lead to patterns. And we've already seen these patterns become languages in passive house architecture, like Monty described in his presentation, like Tessa Bradley of Artisans Group described in a recent presentation. But we need to see more patterns that also deal with quality and accessibility and other things that passive house alone can't necessarily deliver. When we do, we'll create an all-American home that feels relevant and stable for the 21st century, one that lasts and is very specific in its intention to provide a better quality of life for people on this planet, and that's what we're working towards here. Now, in order to be more relevant in a changing climate, we need better building performance. So what's the best system? I think a lot of us are here because we agree that it's passive house. And why? Because it's really good at predicting results. I'm sure many of you who just started to get into this, saw charts from European buildings showing a really close match between what the methodology and the model said and what the actual results were. So that predictability is really important. But what's passive house without a good system of execution? It's a nightmare. It's slow, it's expensive, its quality isn't where it should be, and it's really out of reach for most folks. So, we need good systems to improve that time, cost, and quality. And this is where we feel that offsite manufacturing systems come into play. They offer more predictability, and that can help give the confidence to designers and building owners to do passive house. But in order to address local needs, it can't be rigid. Christopher Alexander says nature never produces the same thing twice. Every leaf is different. So we can't do cookie cutter. We need flexibility. And we think prefabrication, the panelization of building elements, delivers this design flexibility so that we can adapt to local and individual needs while still giving that predictability and that confidence to execute the passive house principles. This flexibility can help make buildings that feel more alive. But if our buildings are what they eat, we can't forget the ingredients. So we need to systematically select low embodied carbon materials. And this is where certain panel systems we feel do need to improve. We'll talk a little bit about embodied carbon analysis in comparison later with Heather. But it is predictable if we can systematically choose these things, predictable results. When we use these three systems together, we get what I call the trifecta of quality buildings. I love passive house because unlike something like net zero, which just focuses on electrons and energy, passive house focuses on comfort of the occupant. So it's more human, it's more alive in that sense. Prefab focuses on the comfort of workers. Collective Carpentry moved inside because, as Rain shares in a video that's on our YouTube channel, his hands were cold. And embodied carbon, as Lucas described, often goes hand in hand with toxicity. So it helps naturally improve occupant health, and embodied carbon is almost often a secondary benefit. The predictability of all three of these systems, creates stability, and that stability means this is a more reliable way to deliver a quality building. And a little hat tip to Artisans Group for the project at the right here before I move on, which really embodies this trifecta. Now, finally, because we were asked to talk about how collective carpentry is overhauling the all-American home, I want to hammer home the point that what I think allows us to do this well is that we're incorporating this trifecta into a global, building system that we call the collective carpentry building system. For our system, it starts with material selection, where performance and efficiency and quality and embodied carbon are considered really upfront. Then we create details which help us incorporate how these materials work to deliver envelope performance, structure, how they'll be fabricated, delivered, installed. We systematize these approaches and we reduce the menu choices. We essentially have no more than 2 wall assemblies, 2 roof assemblies, 2 floor assemblies, but we remain flexible to changes in material grade and spacing and thickness and that kind of thing. In production, we use 3D modeling systems, documentation of the review process, fabrication tooling, production data monitoring, and other systems. But we do keep it human scale. Our shop is a super fun environment. I hope one day some of you will come to check it out. And then, last but not least, we then take material transport and waste mitigation, reduce neighborhood disturbances. We take these things seriously, and we install homes in 5 to 10 days. So that's part of the system as well. All of this works because it's a feedback loop. It's constantly iterating. These relationships between all of these considerations for delivering quality buildings is what I think makes this the right system to overhaul the all-American home. What I'm advocating for here is not that everyone uses the collective carpentry building system. In fact, the reality is that there are many companies out there putting this into place, systems like this into place, and there's room for many more. So the more architects and builders and developers choose these systems over site-built approaches, the more of us there will be. And the better the quality will be, the more competition, the more continuous improvement will drive the price down. I'm going to hand it off to Heather now, who's going to talk to you about how we incorporate this collective carpentry building system into projects we design. We still do plenty of custom homes in our entertaining multifamily structures as we grow, but I think these homes offer something that should ultimately be more prevalent as they are in Europe, where companies like Baufritz are building, almost all wood framed houses this way. My dream is really to see other small companies get into this market in North America, go inside, build panels, learn some tricks, offer a better solution to building a quality home. Thank you.
Thanks, Craig. My name is Heather Mott. I'm the in-house designer with Collective Carpentry. I'll be talking about how we at Collective think the new American home should be built. Spoiler alert, it's passive house, with prefab construction and low embodied carbon materials. Our goal at Collective is to advance the industry in a way that is symbiotic with the environment. There are a lot of barriers to getting there. So to create the path of least resistance, we've developed a design guide, standard details, and pre-designed homes. I'll follow up this information with a case study and supporting analyses. For those of you who have not worked with prefab yet, we build the insulated, airtight structural envelope as panels in a shop, ship them to site flat packed, and install with a crane, going from a foundation to a fully enclosed structure in just about a week or two. The design guide is a resource for architects and engineers to integrate your design with a prefab system. It is not quite ready, but it will be released later this year. You can build just about anything with prefab, but like most things in life, there's an easy way and a hard way. This guide helps ensure that it's done the easy way. For example, a post and beam structural system is preferred over load-bearing interior walls, and drop beams are preferred over flush beams. Second, locate rough openings to be contained within one panel, which is limited by the size of a step deck trailer. We cannot frame rough openings to be split between two panels, so for large windows, the panels are framed around the rough opening. Usually this is with two cripple panels, a sill panel, and a header panel. Lastly, standardize. The pre-cut stud is a really easy way to introduce standardization. It's a favorite among our shop crew. When pre-cut studs are used on a project, it saves a lot of preparation time. It's a little bit like having a sous chef prepare all the recipe ingredients for the head chef to cook with. This guide can be helpful for any prefab system, not just ours. As Craig mentioned, the standard details are another resource for architects and engineers to design for prefab. They show how panels integrate with other envelope elements, such as foundations and windows. I should really be calling these standard-ish details because they're very adaptable. We do not want them to dictate the design. I learned a lot of this information the hard way, and we made this document so that you do not have to. The details are available on our website. It's a little bit like giving away our secret sauce recipe, but ultimately we feel that the world would be a better place if everyone built like this. So we're happy to be open source. You can download them through our website. We used these two resources to inform the designs of our pre-designed homes that were released last year. They are 8 passive house-able designs with controlled customization options. Our goal with the collective homes is to make high-performance construction available to a broad market by reducing the traditionally high cost of design. Sometimes manufactured homes can have a reputation for homogeny and disregard for their context. So we're trying to break this stereotype. As Craig mentioned earlier, integration with the surroundings is critical for hitting high-performance goals. So for this reason, we include 20 hours of customization time with every collective home. This time is used for creating a site plan and orienting the home, selecting appropriate assembly types for the climate, adjusting overhang distances, specifying mechanical systems, and so on. So when we think of the next American home, this is what we imagine. The first collective home was built in Bozeman last year. It is the Kalina Mountain design. It has about 1,500 square feet of interior floor area. We used tools like PHPP and Flixo to inform the designs of all collective homes. And we have tools in-house to help clients complete energy models. But unfortunately, we do not have capacity yet to offer this in-house. We do have a couple collective homes under contract that will be doing the full energy modeling, so we look forward to sharing the results with you all in the future. The Flixo model to the left is our standard detail for wall-to-roof connection, which we use on the collective homes. As you can see, the psi value of this detail is a negative value, and as many of you know, any negative psi value will bring the space heating demand down. We heard recently from the owners of this house that even in 80 and 90-degree weather this past July, they did not need to turn on their heat pump for active cooling. Lucas highlighted the importance of healthy, low-embodied carbon materials. We wholeheartedly agree. So here's a look inside our typical wall panel. We use all wood-based materials and Proclima membranes. Our typical wall panel assembly is shown at the top left, and along the bottom of the screen is a production sequence of a triangular wall panel. The 2x-layer is installed without cavity insulation for running services. Behind that, the plywood sheathing is taped airtight, and the I-joist layer is packed with cellulose to form a continuous insulation layer. As many of you already know, cellulose is a really great material. It's fiber insulation made from recycled newspaper and treated with non-hazardous chemicals for pest, mold, and fire control. Our blower door test results confirm that this system is successful. I'd really like to give a shout out to the crew at 475 because they're always our go-to team for material selection and sourcing. Craig also used the BEAM software to analyze the embodied carbon of the Bozeman case study. This analysis represents our system relative to a high carbon alternative of equal performance. This analysis does not represent the whole house, only the elements that we provide with the collective homes. So this includes exterior walls, roofs, doors, and windows. Our system is analyzed on the left, and the high carbon alternative on the right matches our system's R values, but with rigid mineral wool instead of cellulose in the walls, and flash and bat instead of cellulose in the roof. You can see the difference in net total emissions is substantial. Mineral wool is still a great option, but materials like wood and cellulose are plant-based, which is carbon storing. So some of the emissions from the manufacturing process are offset. So here we are, a conference full of passive house enthusiasts, trying to shift the building paradigm towards sustainability. Early examples of American home styles show that manipulation of environmental factors was an architectural problem out of necessity. In the 20th century, increased standardization led to a boom in housing. But with decreasing fuel costs, less attention was paid to energy efficiency. Moving forward, we need a scalable model for sustainable living that is symbiotic with the environment and promotes a healthy lifestyle. The combination of passive house and prefab provide the scalability and quality that a new era of American building will demand. This would use the passive techniques of the past, the standardization and technology of the present to make the house of the future. Thank you. You guys are building this future. Please feel free to contact Craig or me. We're always happy to do design consultations and answer your questions.
Hello from Philadelphia. And yeah, great presentations. Thank you, Lucas, Craig, and Heather. This was very, very informative and awesome. So I would actually like to go a step back and look at the title again of the presentation, because I really like that title. And so the title of the presentation, The All-American Home, New and Improved. So I think for me, the reason this is so intriguing is that we are not just talking about a few custom single-family homes, right? And a lot of times when these clients come to us, they have already bought into sustainable building practices, right? So, but in this case, for this presentation, we are actually talking about the all-American home, which is so ingrained in the American culture. And we are actually talking about a broad nationwide adoption of high performance or passive house using natural materials, right? So for me, I grew up in Germany. So for me, the idea of the all-American home is just really interesting and also almost a little bit mysterious or ambiguous. It's something that I only had access to until I moved here through just movies or TVs or later in architecture school. And to me, the American home always appeared to be such an icon and representation of independence and freedom, and just the idea of putting the money into something you own rather than paying someone else's mortgage. And it's a great way to invest. So, and it's also something to be really proud of. And these should all be like really perfect reasons to build a really great, resilient, and healthy home, right? You would think. But then I learned that the homes or the houses a lot of times are actually not really seen as a long-term home, but rather a place that grows with you and your needs or your perceived needs, and that it really reflects your identity. For example, you know, the starter house or the 5-year plan or the family home with the garden or then the empty nest. So it's really interesting, right? So that all kind of looks towards these like more temporary like parts in your or episodes in your life. So Lucas, with that in mind, how do you have difficulties getting homeowners on board to care about how their home is constructed instead of investing in visible features for resale value? And what are your strategies and how do you talk about it? Or do you think homeowners shouldn't even have a choice, you know, that they can't even determine how the home's actually built?
Wow, that is a lot. Yeah, I mean, it's great questions, great context. And being married to a culture anthropologist, I think about culture a lot and how that might be our single biggest barrier in making these shifts. So much of the time, the people who are interested in working with us, either for our consulting work on, you know, retrofitting their home or designing a new home for them or buying a property that we've designed and built, they don't want to be perceived as weird, right? As buying something different than the average. This is especially true in Phoenix. And our homes are frankly quite weird in, I would argue, a very positive way, but they're very different, right, than the average in aesthetic and layout, et cetera, right? Let's take square footage as an example. One of the core principles of sustainability is don't build bigger than you need to, right? Like no matter what, you don't need to consume more good materials or bad materials than you need to. So I like this concept of usable or maybe enjoyable square footage of a home is what we should actually list. there's a lot of 5,000 square foot mansions built, in Paradise Valley, very fancy part of Phoenix, where roughly 1,000 square feet of the home is really enjoyably usable because they've done really poor assembly details with south facing glass and all that stuff, and the house is just overheated with gigantic air conditioning bills and all kinds of pressure imbalance issues and air quality issues. So like, people buy these fancy mansions thinking they're creating this castle to live in, but frankly it's like they live in 3 rooms of the house and they're not happy about it. So the buildings we build, maybe it's 2,400 square feet, but every single square foot is going to be an enjoyable, comfortable, healthy space to be. So you actually get more usable square footage if you make all of the square footage good. Does that argument translate to, say, the real estate professionals and brokers of the world? No, it doesn't. Not even close. Like, square footage is still king, right? But that fundamental concept of get good value for every square foot you're paying for, and ask what is this made out of? The fundamental concept of, as Craig was mentioning in the presentation, people have made major shifts towards healthier diets, more exercise, all this other stuff, caring about what we wear and what we eat. We need to apply that exact same logic to what we live in. I was talking to my good buddy here in town, Ray Clemens of Natural Building Works, who's designing and building that Dancing Raven project with me. And we were talking about a project where people did straw bale walls and then spray foamed the roof. And it's like, wow, that is a disconnect, right? So getting people to view their building materials that they use as equally important to the clothes they wear and the food that they eat. When we take the time, or people allow us to have the time to educate them on that, then we can shift the market, maybe one conversation at a time. We've been trying to do a bunch of PR to have this conversation more broadly, but it really does kind of actually happen at a, small conversation scale.
Yeah, no, I agree. And I mean, what's interesting too about then, I guess my next question is going to Craig about, like, I guess some people are just not really familiar with all these building materials, right? Like straw bale or even wood fiber insulation. The really big advantage of prefabrication is that you make a panel and that becomes your spec, right? So the builder, the client, nobody really has to think about it anymore, because a company like Collective Carpentry already did that. And they're basically saying, this is what you get. Don't think about it. Let us take care of it. Do you think that is helpful with your discussion, Craig, to convince people that this is really not a big deal and difficult?
Yeah, I think I always come back to the word like confidence when we talk to, whether it's architects or developers or builders or homeowners, about the style of construction that we do. I think we give them a lot of confidence because of the repetition, because of the fact that we have these systems that we've developed and improved over time. And because we're doing, one very, specific part of the building process, which is, the high performing building envelope, we're focusing on like, what are the best improvements to make in that space? We're not doing the entire building. We're a little bit more than just, framers, but because we're including insulation and high performance membranes and tapes and air tightness and how that all comes together on site too, with the installation quality and everything like that. That confidence to kind of, we want to do something better, but we need to know that the company that's going to put this into place is going to do it right. That's where, I think where prefabrication has a leg up from site builders who also just, want to learn these things, but need to have this repetition in order to get there. So, that's why I sort of make the case for more companies like us existing, because I think it's a hugely attractive thing for builders too, to be able to say, my client wants a passive house, and that's cool, but I don't know if I can do that. Or, I know I can do that. I just know it's going to be really expensive for them. And this client doesn't have a budget. So, the sticker price on prefabrication is higher, right, than the sticker price on a high performance home built on site, because I think there's a lot we know about how hard it is to do this. and about some of the overhead that we have in putting this quality into place with the physical, factory, or more of a workshop. But I think there's a question coming in on the chat of like scale of all these new homes going up in Orlando and that kind of thing. It's really true that we are a very small company, right? We don't have the scale to compete against those developers. And so, we have to think about like how we can, get these systems right when we're small, but then maybe share it with more other folks like us. But it's still better than every single builder needing to be educated on high performance building practices and materials. Because every single builder, diffusing that information across that kind of number of players in the market, it's generational change like these changes generally happen over a generation, over 20 years, because builders grow up learning things from who they apprentice under, so we're kind of introducing this like kind of shortcut to saying like we've already figured these things out and we can deliver it at this cost, it's fixed, and is this a route you want to go or not? So
yeah, and I mean, this is kind of
question.
Yeah, and I think that's kind of the discussion. How do we actually scale this up so that these large scale developers can run with it as well, correct? Because we're talking about the all-American home, so we want this to be adopted in a really, really large scale. And I think that makes a point, just thinking about prefabrication, that there's going to be an opportunity to create a lot of homes in a really, really short time frame, and that if we do that, we better do it right? So we have to really think about how to do it well. So my next question is for Heather. So the other thing that I'm so curious about is the American home really seems to reflect an identity, right? So what we talked about earlier, that it grows with the needs of the family. And just from me watching TV series coming from the US, I mean, the setting's already there as soon as you see the home of the character, right? So it's so important to people how they represent themselves. But you are kind of coming in with model homes, and I can imagine there's a lot of clients that want to change that, or want to change your model homes. So is that possible, and how do you do that?
Yeah, great question. It's something that we've definitely built into the process for the collective homes. And customization is really important to the individual. So from the beginning, we have a few different options of homes for folks to choose from, both options of size, bedroom count, things like that. And then from there, we've taken it one step further, and homeowners also have a choice of different roof options. A really simple switch from a gable roof to a flat roof totally changes the look of the building, but still keeps a lot of the efficiency that we've built into the project. So that's sort of one of the easiest ways to do some customization for adapting to people's preferences. But beyond that, we also provide complimentary design time for all of our collective homes. And this is really important because we want to make sure that the building is integrating with the site. Every site needs a different foundation type. You need to respond to the slopes, the views. It's also really important for, of course, energy performance. So we'll do a sun path analysis and check our overhangs, make sure that they're projecting at a good distance for optimizing our solar heat gains in the climate. And then it's really important for just making sure that people like the look of their home. So we'll spend some of this complimentary design time doing material studies, and sometimes people want to rearrange things in the interior of the home, which we're always happy to accommodate. If the homeowner is choosing substantial changes, substantial customizations, then we engage in a contract that would be very similar to an architect. Just like if you were designing something from scratch, the world is your oyster. You can make as many changes as you want. And my job as the designer is to guide them through the project, much like an architect would, and also to advise on any changes that might incur an energy penalty. But yeah, we don't want to create a bunch of cookie cutter homes, and we want people to feel like this is truly their home, that they had a hand in the design. We're just trying to streamline the process and eliminate some of those traditionally high design costs with our process.
Mm-hmm. Great, thank you. And you do offer some energy modeling to just look at the performance of each of the homes as well. Is that correct?
Yeah, so the original design of the homes was designed in PHPP, and we were targeting passive house low energy. But of course, without a location, we just chose a location to model these in that was a cool temperate climate, which is a climate that we build in quite often, where we anticipated these homes might go. And we did achieve low energy, but we do not offer the energy modeling when a homeowner purchases a home. That's sort of an added cost. It's always recommended just to do some checks as you're customizing things, moving and changing windows. We would love to offer that one day. Right now, we don't have the capacity. I'm the only designer. But my dream is that as we build out this design side of collective carpentry, that just becomes something that you get automatically with your collective home. You get the complementary customization time. You also get the corresponding energy model so that we can show you exactly what your energy demand will be.
Yeah. So that's actually really interesting. And Craig and Lucas, you both talked about using the beam tool for carbon counting as well. So I would like to know a little bit more about that. But my first question is, do you use those results or those modeling tools to communicate with your clients? Is that a useful tool to get clients on board with using different materials once you show them what kind of impact it has? Or Heather, with the energy modeling, is that maybe communication, the WWOOFy model, a communication tool to convince people that this is the right way to go?
I can answer. I want to answer quickly and then pass it to Lucas because I think he has more experience with it. But I only recently really dug into the Beam tool because we were sort of told from personal feedback from Chris Magwood, who's on, head of kind of developing it with Jacob, that like you guys are just doing all the right stuff already. You're using wood, you're using cellulose, you're not putting in a bunch of sort of high penalty items. But I think, for us so far, it's like we kind of just don't necessarily really get into why what we do is so much better than the alternative. We just sort of exude confidence in what we do and say, this is how we do it because we believe it's the best and most sustainable approach. Now, since looking at the embodied carbon, the Beam tool, I now have a little bit more like reassurance in addressing questions that in the past I might have just kind of given more general answers. Now I have more statistical answers that I can really answer these questions with a lot more confidence. So I'll just go from there. And I think it'll change maybe what we do and recommend in future.
Mm-hmm. Thank you.
And I'm noticing we're getting kind of short on Q&A time, so I'll try to keep this answer brief. But just like energy modeling, there's an evolution of tools that occurs over time, right? We have now reached the point where the accuracy of these carbon modeling tools from Beam to EC3 to whatever else might be out there are accurate enough to be very meaningful. They still have a ways to go in terms of precision. Oftentimes you're choosing, say, a market average for cellulose because the exact cellulose you're using doesn't have an EPD yet. That's market development. That means call that company and ask them to please get an EPD, right? We can all work together to help improve these things. So one of the things you can do if you're interested in helping improving carbon impact of the built environment is ask everyone you buy a product from, do you have an EPD? And if they don't, say, well, that makes me curious about buying your product. I'm not sure I really want to. Please get one. And we can really have a massive shift in our industry if we force companies to do this. That's one thing to say. On the client communication side of things, as Craig mentioned, there is often kind of incomplete conversations around carbon, where it's like, well, yeah, we know that's lower carbon, but exactly how much, right? So to have a tool that can really quickly and easily summarize how different certain scenarios are is incredibly powerful, and that they put it into traditional accounting language, I have found is particularly useful for our, say, financially savvy homeowners or developer clients that we're working with. They like this format of talking about these things. It's carbon accounting, and they can get down with that. So that tool Beam has been particularly useful in the residential space. And then I often go to the EC3 tool because they have an incredible database of EPDs out there. So those are kind of my two favorite carbon modeling tools right now. And
Great.
yeah, thank you guys. That's awesome.
Thank you. So I think we're done with our time that was allocated to us. So thank you everyone for these great presentations and answering all these questions. And I'm looking forward to seeing everyone in Denver next week.
There we go.